All right, so we're getting into chapter 2, which is going to start you on your proofs. If you haven't heard anything about proofs, you should have, because they can be difficult. So the key to your proofs are knowing your flashcards, number 1. You have to know those inside and out, and you have to understand what it is that you're memorizing as well. So if you don't understand those flashcards, you need to bring them in and ask me, what does this mean? So today we're going to talk about what's the difference between inductive reasoning and what's conjecturing. So in science, you should have made conjectures, correct? What's a conjecture? What would a conjecture be? You have no idea. You've taken science all the way up until now. You've never heard about the scientific process. Oh, please. Really? What if I arrive at a crime scene, I assess what has happened, and let's say that this is what I happen to see. I come into this room, and there's a body laying on the floor in a pool of blood. And Katie's standing over the body with a bloody knife. What's my conjecture? That she killed that person. Is it necessarily true? No. So we can make conjectures based upon an educated guess. Some conjectures that you're going to see are true and some are false. So a detective's job is to prove a conjecture false. If you can prove it false, it's much easier, it's much more difficult to prove something false than it is to prove it true. Because if I said, with Katie standing over the body with a drippy bloody knife, it's much easier for me to say she did it. There could be other explanations for it, couldn't there be? What's an explanation? She found the bloody knife and picked it up, right? Maybe she walked in the room before me and was shocked and picked it up and was like, what happened? Could that have occurred? Yeah, it's possible. So if I can prove that my original conjecture is false, it's much more difficult to prove that in her case, because I just have to take her word for it. I'd have to find other evidence to prove it. Your flashcards are your evidence to disprove things. All of your theorems, your postulates, your corollaries that are on those flashcards and definitions can disprove a conjecture. So, we're going to use some various reasonings. Inductive reasoning would be looking at several specific situations to arrive at a conjecture, which is your educated guess. Oftentimes, detectives use inductive reasoning based upon their experience, based upon facts at the crime scene. So they're going to gather evidence. And that's how they're using their inductive reasoning. They're gathering their evidence, they're using their experience to come up with this conjecture, this educated guess. Hopefully when you come up with a conjecture, you come up with a true one and not a false one. Those of you taking the exam, if you can't see, move over here to where there's some safety lights to where you can see. Or move a desk over to where there's a safety light, because I know that green paper is really hard to see. All right, then you're going to be responsible for finding a counterexample to prove a conjecture false. A counterexample would be basically evidence that says this is why that conjecture is false. So in Katie's example, maybe I would find instead DNA on that knife that does not belong to her. Because oftentimes when somebody is stabbing somebody, they cut themselves. So if I find somebody else's blood or DNA on that knife and it's not Katie's, then that leads me to believe that there is somebody else at that crime scene. And so I can use that example to prove the conjecture false. So I'm going to give you 4 different geometry conjectures. And oftentimes with geometry, when we try to prove a conjecture false, you can draw a picture. When you draw a picture, I need you to be as specific as possible. So can I take that away? Okay. So we're going to start with, I need a sticky note. Two sticky notes. Okay, so I want you to write, you don't have to write the directions up here, but I want you to write the given and the conjecture. So example number 1, given, and that's ray OB bisects angle AOC. The conjecture is that angle AOB is congruent to angle COB. There's no picture given. The first thing that I will do is look at that given and try to determine, without looking at the conjecture, what it is I should have concluded in the first place. Because here's what's going to happen in your proofs. You're going to be given that information, ray OB bisects angle AOC. And you have to come up with some reasons to prove that to use that to prove something else true. So this is basically a mini step in a proof. What are you supposed to conclude if you have a, what's a ray called that bisects an angle? If you have a ray that bisects an angle, what's it called, Seth? What kind of bisector? Be specific. What's it bisecting? An angle. So it's an angle bisector, because there's a difference between an angle bisector and a segment bisector. What does an angle bisector do? What does it create? Two separate angles, but what kind of angles? Two congruent angles, right? So let's draw a picture of an angle AOC. It doesn't matter if the angle is acute or obtuse. So I'm going to draw a big angle. Where's my vertex on angle AOC? Oh, the middle one, right? And so it doesn't matter where you put A and C, or what order. Put one on one side and one on the other. And it says that ray OB, so it must start at O. B must have to be in the interior here. Ray OB, and it specifically says it bisects it. So if it bisects it, it absolutely positively creates two equal angles. That part's true, because that's part of the definition of an angle bisector. Then let's see what their conjecture was. Let's see if the conjecture is true. It says that angle AOB is congruent to angle COB. Is that what we were supposed to conclude? It appears true. Is there any way that I could draw a picture of an angle bisector and not get two congruent angles? Is there any way? No, because by definition, I'm going to get two congruent angles. All right, so there's that one. Then, the next one. Here's example 2. Let me erase that. You always have to assume that your given is true. We always assume our givens are true. So this time I have angle CAB with segment BD such that D is on AC. The conjecture is that segment AC is perpendicular to segment DB. If you're taking your test, you shouldn't be listening to my lecture. You should be taking your test because you'll run out of time. I need to try to draw this false. Remember, your job is to be a skeptic. Your job is to prove that it's false. So we have to come up with a false example. That's what I meant by coming up with a false example, to prove that that's not true. And so it would be easy. It's easier to try to make it true. So let me see if I can make it true. So I'm going to draw an angle. CAB, A is in the middle. So A is my vertex. Then here is C, and here would be B. So here's an angle. And again, you could have drawn an obtuse angle as well. With BD, such that D is on AC. So I have to put D somewhere here on AC. And it's saying that AC is perpendicular to DB. So I could make a perpendicular line going from B to a point D. So that's true, right? Am I right? Is there any way that I could write that so it's false? So that right there is true. It's a true picture. But can I create a picture such that D is still on AC, but this line is not perpendicular to that line? All I have to do is move D. What if I move D over here? Is this now perpendicular? There's my perpendicular marker. Is that perpendicular anymore? No. So if I take away this line, that would be the true line, and I put D over there, do you see how it's false now? So sometimes that given is true. I'm sorry. This given is always true. Sometimes that conjecture can be true. But in this case, it's false, isn't it? I could have put D over here, and it would have been false. The only time that that given, or I'm sorry, that conjecture is true is when D is right here in that spot. So you're going to want to try to make the picture true. If you want to start out with a true picture and then look at that picture and go, is there any way that I could draw it so it's false? That might be easier for you. But you need to try to make it false. So is this conjecture true or false? It's false, so write false on there. And then there's my counterexample. So this is your counterexample to prove it's false. You do not have to have a counterexample to prove something's true. Although oftentimes I'll still draw a picture just so that I can see, is it true or false? Is there any way that I could draw it so it would be false? And then this was their picture. So they drew an obtuse angle. And again, if I try to go from this line, here's my perpendicular marker, this is definitely not perpendicular to B. In fact, with an obtuse angle, there is no way that I can draw D being on AC at all. Not on an obtuse angle. With the acute angle, I could draw D being perpendicular, but on this obtuse angle, I can't even draw it in there. So the obtuse angle is the super false counterexample. All right, so look at example 3. Bless you. This time you're given two angles, angle APT and angle TPS. You might want to note that those two angles share 2 points, T and P. They share a vertex, P, and another point, T. What can you conclude? Oh, well, they already say it's adjacent angles, right? They shouldn't have had to tell you that. But because you're starting out, that they are. But the fact that they share a point and a vertex, they have to be adjacent. And then they go on to say that ray PA and ray PS, which are coming from the vertex, are opposite rays. And they're also, PA is on the first angle and PS is on the second angle. So we have to draw. You do have to make sure that your given is true in your counterexample. If you draw a counterexample and you don't have ray PA and PS as opposite rays, it doesn't work. So I have to follow that given to the letter and then look at the conclusion, the conjecture, and see if I can make it false. So their conjecture is that the sum of the two angles equals 180 degrees. Bless you. So we're going to draw the given. I'm going to put everything in the given that it says. I've got two angles that are adjacent, but we have opposite rays. So if we have opposite rays, by definition, that's a straight line. My vertex of the two angles are P, and they said that from P to A, and from P to S, those are opposite rays, so this is part of my given. I have to have that in my picture. And then I have to draw T anywhere here. Now that's where I can change where T is. I can draw T anywhere around here that I want to. I'm going to start off with it here. T is the only thing that you're allowed to move on here based upon the given. So here's APT and here's TPS. Are these both adjacent angles? Do they share a side? Okay, so I have to hold the given true, so that part's true. And I have PA and PS as my opposite rays. So I can change this all I want. Is there any way that I can change where T is so that these two angles do not add up to 180 degrees? If I change T all the way down here, won't I now be looking at these angles here? Won't they still be 180 degrees? There's no way to draw that picture false, is there? Everybody's picture might be slightly different, but you're going to have two angles that form a straight line. By definition, they add up to 180 degrees. They're defining for you a linear pair, aren't they? Okay. So what's your conclusion about that conjecture? It's true. What do I do with my eraser? Oh, I'm standing on it. How nice. All right, so last one. All right, so last example. This time you're given angle TWP and angle XWP. Again, don't they share a vertex and a point? And again, they're telling you that they're adjacent angles. They didn't have to tell you that. You've got to start to conclude that if two angles share a vertex and a point, they've got to be adjacent. The conjecture is that the two angles are congruent. What's the only thing that I have to hold true in my given? What's the only thing that they're stipulating in the given that has to be true? Yes, Alice. You have to draw two adjacent angles. You can draw an adjacent acute and obtuse angle. You can draw two adjacent acute angles. You can draw two adjacent obtuse angles. You just have to draw, you can draw a linear pair adjacent angles like we had before. You just have to make sure that they share a side. So I could draw, I have a number of things I could draw. I could draw this. And I could draw this. Are those two angles adjacent? Are they congruent? Yeah. I could also draw this. And if I put these markers in here like this, there's two more different types of angles that are adjacent but congruent. So a lot of you are going to say, well, this is false. This is true. Because I can draw those. Can I draw it false? Sure I can. And here's where I would be really specific. Because they're saying that the angles have to be congruent. If you're going to draw it false, I would put in, because you want to make sure that the angles are different measures. So I would actually put in degree measures. So I would draw one that's blatantly a different size than the other. And if this is a single arc mark, put double arc marks in there. And so this one would have to be X. Or make this like, 40 degrees, and this is 80 degrees. You're telling me right here, I don't want this one. You're telling me right here that these are not equal. So here's your counterexample to prove that conjecture false. You only need one situation to prove it false. This is just one example of what you could have drawn. I could have drawn this one, but change where P was and put it over here. So a lot of you will just draw it like that, but I want you to be really, really clear and say that, oh, this is 30 degrees and this is 150 degrees. False. Be really clear. Because if I'm not sure, because a lot of times some of you will have drawn the first one I had of this one where they look similar, and then you put a single and a double arc mark in there, or you don't put anything in there and you just say false. And I'm like, well, they look the same. If it even remotely looks like they're equal, and you're saying it's false, then I'm not going to accept that counterexample. You need to really prove it to me and support your conclusion. All right, questions on that? Okay, you're going to get some practice at it in your homework, so I'm going to get you started on that after your vocab quiz. Yay.